When you see a massive ship, you might think about engines, captains, or the towering stacks of containers. These vessels are marvels of modern engineering, crossing oceans and braving the elements. But there's a hidden hero that rarely gets the spotlight. Have you ever wondered how such a colossal ship stays perfectly still in the open ocean, even when battered by wind and waves? It's not just the anchor itself, it's the chain that makes all the difference. The anchor chain is the unsung hero of the maritime world. It holds ships steady against storms, powerful currents, and the relentless pull of the sea. Without it, even the strongest anchor would be useless. Imagine the force of hundreds of thousands of tons, pushed by nature's fury. Wind, waves, and tides, all held in place by a single chain. The pressure is immense, and the consequences of failure are unthinkable. If that chain snaps, disaster strikes. Ships can run aground, causing environmental catastrophes, massive financial losses, and putting lives at risk. The chain is the last line of defense. You might wonder, why not just use rope? After all, ropes have been used for centuries to tie up boats. But ropes would quickly shred on the rocky seabed, and they simply can't provide the weight or durability needed to keep a ship anchored in place. They're no match for the harsh conditions below the waves. The chain's weight is crucial. It keeps the anchor pulling horizontally along the seabed, helping it dig in deeper and absorb the shocks from waves and wind. This horizontal pull is what gives the anchor its holding power. These aren't ordinary chains you'd find at a hardware store. They're feats of engineering, forged from special steel to withstand unimaginable forces and the harshest environments on Earth. Each link is a product of advanced metallurgy, precision engineering, and brute strength. They're tested to their limits before ever touching the sea. Making these chains is dirty, dangerous work. It requires incredible skill, teamwork, and a deep respect for the forces they must withstand. The anchor chain is a lifeline, literally. It's the difference between safety and disaster for every ship at sea. Today, we'll meet the people who forge these giants, the unsung craftsmen behind every safe voyage. We'll see how these chains are made tested and sorm, chains are tested, and why their strength is so vital to the world's shipping industry. So let's dive into the world of the world's strongest anchor chains and discover the incredible science and skill that keeps ships safe at sea. You can't make a world-class anchor chain from just any steel. These chains start with a special alloy, high-grade steel, engineered for toughness and corrosion resistance. The recipe is precise: iron, carbon, plus manganese for hardness, and nickel, silicon, and chromium to fight rust. Saltwater is brutal, so this steel must survive years on the ocean floor. Grades like R4 and R5 mean even higher strength. Each step up is more muscle. Too much of one element and the steel's brittle. Too little, and it's weak. Every link is a calculated blend, a triumph of material science. This isn't just metal, it's the result of decades of engineering. The right recipe is the foundation for everything that follows. Without it, the chain is doomed before it begins. These chains are born in massive foundries, industrial giants in shipbuilding nations like Spain, China, and South Korea. Inside, the air vibrates with the roar of furnaces and the clang of steel. Giant hammers, white-hot metal, and sparks fill the scene. Everything is oversized. Furnaces melt tons of steel. Presses exert thousands of tons of force. Cranes lift links heavier than cars. The factory itself is a machine, built to tame steel. Located near deep-water ports, these foundries ship chains directly to vessels. The logistics are staggering. Hundreds of tons of chain, loaded straight onto ships. From raw steel to finished product, it's a masterclass in heavy industry. Here, human skill and monstrous machines work side by side. This is where the world's strongest chains begin their journey. It all starts with giant bars of alloy steel, cut into precise slugs by massive shearing machines. Each slug's length determines the final link size. Precision is everything. The slugs are loaded into a furnace heated to over 2,200 degrees Fahrenheit. Workers watch the color, gray to cherry, red to white-hot yellow, knowing exactly when it's ready. Timing is critical. The steel must be shaped while it's still glowing. Cranes or robotic arms move the hot slugs to the forging line. Every step is a race against cooling steel. The transformation from bar to link starts here. It's a blend of brute force and exact science. The real show is about to begin. The process begins with a glowing steel slug, heated to a brilliant orange in the furnace. Hydraulic rams then bend this red-hot metal into a perfect U-shape, applying immense force with precision. The transformation is both powerful and mesmerizing, as the once rigid steel becomes malleable under the intense heat and pressure. Next, the open ends of the U are brought together by dies, forming an oval. In a flash, a surge of electricity, hundreds of thousands of amps, courses through the metal. This is flash butt welding, a process that fuses the ends together in seconds, creating a seamless, incredibly strong link. Sparks fly as the metal is joined, ensuring there are no weak points. While the link is still glowing hot, any excess metal from the weld is quickly trimmed away. This step is crucial for achieving a smooth, uniform finish, and it ensures that each link will fit perfectly with the next. Before welding, each new link is carefully threaded through the previous one, connecting them together. This meticulous assembly, whether done by hand or machine, is what builds the chain, one link at a time, ensuring strength and continuity throughout. A steel stud is then pressed into the center of each link. This small but vital component prevents the links from kinking or distorting under heavy loads, and it adds significant strength to the finished chain. The stud link design is a hallmark of quality anchor chains. It keeps the links from twisting, which is essential for durability and reliability, especially in demanding marine environments. After shaping and welding, the link is left to cool, solidifying its new form. This cooling process is carefully controlled to maintain the metal's strength and integrity, preparing it for the next stage. Throughout the factory, machines and skilled workers move in perfect harmony. It's a fiery, precise dance, each step timed and executed with care, blending human expertise with mechanical power. Every finished link is carefully inspected, a testament to both engineering and craftsmanship. Only those that meet strict standards move forward. The chain grows, link by link, in a relentless rhythmic process. Each addition strengthens the whole, building a chain that can withstand the harshest conditions. Rigorous testing follows, with every step focused on strength, reliability, and safety. Chains are pulled, twisted, and examined to ensure they'll never fail when it matters most. This is how a lifeline is forged, through heat, force, and unwavering attention to detail, creating chains that anchor ships and safeguard lives at sea. Making the chain is only half the battle. What comes next is a relentless series of tests, designed to push every link to its absolute limit. Before it can ever be trusted to anchor a ship, it must be proven strong enough to withstand the fury of the sea and the weight of responsibility it carries. The process begins with heat treatment. The chain is reheated to extreme temperatures, then rapidly quenched and tempered. This relieves internal stresses, toughens the steel, and ensures the metal structure is as resilient as possible. Next comes the proof load test, a brutal trial where the chain is subjected to millions of pounds of force, just shy of its breaking point. This simulates the harshest conditions it might ever face at sea. Inspectors meticulously check every link for cracks, stretching, or any sign of weakness. Even the tiniest flaw means the entire chain fails the test and is rejected. To guarantee ultimate strength, some links are sacrificed in destructive break tests, pulled until they snap, so engineers can verify the chain's true breaking point and ensure it meets or exceeds strict safety standards. After these grueling tests, non-destructive examinations follow. Magnetic particle inspection is used to reveal surface cracks invisible to the naked eye, while ultrasonic waves penetrate deep into the steel, searching for hidden flaws or internal weaknesses that could spell disaster. Only chains that pass every single test, no matter how demanding, are certified for use on ships. The standards are unforgiving. Perfection is the only option, because lives and fortunes depend on every link. Each link is carefully measured, thoroughly inspected, and finally stamped with approval, marking it as worthy of the sea. This rigorous process ensures that when a ship drops anchor, everyone on board can trust their safety to the chain below. The chain's journey from forge to ship is a gauntlet of tests, a testament to human engineering and dedication. Only the strongest survive. That's what makes these chains legendary. Unbreakable links, forged by fire, tested by force, and trusted by those who sail the world's oceans. The numbers are staggering. A single link for a supertanker can be over 3 feet long and weigh 800 pounds. A full chain can stretch half a mile and weigh over 200 tons, just the chain, not the anchor. Offshore platforms use even bigger chains, some links weigh nearly a ton. Shell's Prelude FLNG mooring system totals 30,000 tons of chain. These chains are built to withstand decades of storms and currents. Even the world's largest cruise ships rely on these steel giants for safety. When the anchor drops, hundreds of tons of steel roar to the seabed. Hidden below the waterline, these chains are silent guardians. Their size and strength are a testament to human engineering. Every ship, every platform, depends on this steel lifeline. It's humbling to realize what's holding these giants in place. Making anchor chains is a partnership between powerful machines and skilled people. Machines provide the muscle, bending, welding, and lifting steel that no human could move alone. But it's the workers who bring judgment, experience, and precision. Forge masters, crane operators, and inspectors, many with decades of experience, read steel by color and sound. Safety is paramount, protective gear is standard, and every move is calculated. The work is hot, loud, and demanding, but there's pride in every link. These workers know their chains protect lives and billion-dollar assets. It's more than a job, it's a craft, a legacy passed down through generations. Every chain is a promise, forged by human hands and minds. When storms rage, crews trust the work done in these foundries. The responsibility is immense, and these teams rise to the challenge. They are the unsung heroes of maritime safety. After all the forging and testing, the anchor chain is more than steel, it's peace of mind. For sailors, it's the last line of defense when all else fails. A weak link isn't just a metaphor, it's a real danger. History is full of disasters caused by failed anchor systems. That's why regulations are strict. Perfection is mandatory. Trust runs from the steel mill to the ship's captain. Every link is a chain of trust, forged in fire and skill. The world's strongest anchor chain is a promise. When the seas rage, it will hold. Next time you see a ship, remember the lifeline hidden below. It's a story of fire, steel, and human ingenuity, and it's what keeps maritime commerce moving safely.